volumes, their size are increasing. So we are also having a model, their output, their inference is also having a kind of, at another level. You can say the accuracy and their predictability has increased. So if you see this title, it says the GPT will have a PhD level intelligence, and maybe they launch it in a year. But this Mira Murati has already predicted that we'll have this GPT which will be launched in near future will have some kind of a PhD level of intelligence. It means a kind of intelligence we human aspire for, right? We all are human. We have a limited understanding of a data, understanding of environment, but when we process and we give data to the AI models, so how they process it and they give you response which are very the amazing and kind of a level that is matching to the human intelligence. So that is why this a kind of this discoveries are going on, and due to this again the GPTs and the kind of TPU they require to process the data and again to have the this a kind of AI models, sophisticated AI models and the algorithms, right? So now let me define this multi-model term and what is multi-model, right? So as you are aware of this term, and maybe you might have interacted with GPT's model. So you might have given some of the images to GPTs, and obviously they process it and they give you the response. For example, if you have given some images of, let's say, important documents, and you try to understand what is written in this, this document, and you just want to understand at a human level. So again, if you have given this kind of a prompt to GPT model, you might have seen they have given you some kind of a response in a natural language, right? So again, that is a one model modality of the input that you have given to the GPT. So it's a systems that can process. Again, multi-model is often a model, right? Or a system that process and integrate informations from multiple types of data or modality. Okay, so modality is nothing but the types of data we give to the model. For example, text, images, audio, videos, to make more comprehensive and accurate predictions or decisions. So just think of a chat GPT where you are giving some images, audio and video to transcribe those the audios and videos to understand what is there in those transcriptions and what it talks about, right? So there are also some of the algorithms which makes it possible. So the concept you can say is the clip. So again, the clip is developed by OpenAI, and again, you might have seen this clip if you go in the OpenAI websites. Will have this clip model, and they understand the images and text together. For example, I have given one image to the clip model, and I asked some questions related to that image. So again, they will give some of the informations, the textual informations, the visual informations, okay? And they give you the response. And I'll also explain that how clip typically works, right? And there are also something called, the visual question answering. And if you have any models which are trained on top of this kind of models, visual question answering, I'm putting some of the images and questions about the image. It generates some of the textual response. So textual response is nothing, but it's more of a response. If you see this one, it's a more of a textual response, generate a textual response. It's more of a human readable response where a human can understand, okay? So again, in visual question answering, you have a sum of the models that combines the language understanding as well as the vision understanding. If you see this one, vision and language understanding all together. And then again, they interpret and respond you back. So whenever you see the response of any GPT model, you'll see some humans are writing, some humans are replying you in terms of a response. It looks like some human is talking to you. That is the beauty of LLMs. LLMs are nothing, but it is used for reasoning the model. It's used for reasoning, to bring the reasoning in front of a people, right? So again, there are also some of the model is speech to text, and maybe the text is speech, where you will have some of the audio data, and then audio data is pre-processed, transcribed, and you get something, the response in a language that you understand, right? So these all are the areas where I mean, people can work, and they will have come up, they can come up with some kind of a research work. And also a lot of research are going on this clip, visual question answering, right? So these other modality, people used to work on text to text, maybe text to image, but these all models where you can also create from image to image, right? So during older days, we had some of the interfaces, had this Google, you can say the Google search engine looks like this. And whenever you used to search some of the images before your sophisticated clip model or GPT models. So if you search in Google, you used to get this kind of images. So if you search this a dog on a foggy day sitting on a beach, you might have got some of the the images are displayed from some of the maybe some databases of static databases where it is there. It is not a new content. It is already there in some of the databases, and they pulled out for you through the research mechanism. Okay. So there is some algorithm that I want to talk here. So the Google typically works on BM25. There is one algorithm called BM25 that is for the keyword search. For example, if you have been given a task to create algo only through this keyword search, you do not require a semantic search. So the BM25 is algorithm where this Google also works. So if you see these results are due to this BM search algorithm that runs in the background of this Google search engine, right? But again, if you see, when this you can say a website was augmented with GPT-3. When GPT-3 was introduced in this u.com, and then the result was typically different. It was a bit different because they have introduced this GPT-3 model where a new images was being built based on your textual representations. For example, your input was a dog on a foggy day sitting on a beach. Okay, it's not pulling data from database, but they are also creating new images. As I explained the term, I haven't explained the term clip, but we talked about the term called clip. Okay, so clip is nothing but a diffusion model. There is a concept called diffusion. So based on this diffusion concept, they are creating a new image from your textual representations. From your textual input. For example, a dog on a foggy day, they will use this diffusion concept, and they will generate some of the new images, and you will see that how it typically create a new images, right? So again, we have some of the text to image generations. Okay, so text to image is also interesting one. If you see this text to image generation, so before the GPT, when we have this GPT model, so at that time there was something called okay. So text to image model, again they are using this clip concept. Okay, so this was the early the version of clip model. You'll see the images are a bit blurred, and you'll see it's not a complete image. It's like the images which are generated, and it's a premature images. Yeah, for example, a brain riding a rocket ship heading towards the moon. This is our descriptions. This is our input. This is our prompt given to clip model, right? And if you see this image, you have seen the exact image, something, the similar to our textual representations, okay? So text is being converted into some image. But if you see this image on the right side, Okay. If you see this image on this right side, there is a brain, there is a rocket ship, okay, and there is a moon. If you see this image has the all the descriptions of the text, this prompt, okay. But from where this image, displayed on the screen, it is not in the database. If you find this image in the Google, you will not find this image. Okay, it's a new image that is being created through this diffusion concept. Okay, if you see, there are also few of, you know, if you see few of the prompt, a window manufacturer, adjust a window. You'll see that there is a one image of a person, doing some adjustment in the window, right? But if you see this eyes and this hands and everything, it's a premature. I mean, a kind of, it's not like the exact image that is being created, right? But again, it is aligning to our textual representation, our textual, the prompt, right? But again, it's a you can say the version one of the clip model, right? But now as model gets matured, our images, we are passing it through diffusion concept. Our images similar to the one which we typically see through other software that we typically design, right? It looks similar to the human, right? So again, we'll see the concept of this clip. Clip is very important in text to image generation. And again, image to image that you can create through this contraceptive language image pre-training model. Okay. So typically this clip is one of, can say the advancement of GPT, OpenAI models. We used to have this transformer model, GPT-1, GPT, 2, GPT-3, GPT 4.0 or something. Okay. So as GPTs, their versions gets improved, their response capability, their reasoning capabilities has increased. Parallelly, in the clip side, the text to image generations or maybe image to image generation, the clip has played an important role, this algorithm, where we can leverage, our text prompt gets converted into image. Okay, and we'll see that how this, the clip model or clip algorithm typically works. We'll see the concept. Okay, so clip obviously has this, as I already defined. This is one of the algorithm of, understanding your natural language. Okay, and they learn from this language supervision. Okay, this is again, it's a method. Okay, and algorithm. Okay, clip. And what clip does, clip is again a pre-trained model. They have this, the joint images of text and image embeddings. Okay, and clip was trained on 400 million images and text pair. Just imagine it, how many images pair they have in training data. 400 million images. Just think of a CSV file where in the left side we have images, and on the right side that you have this text descriptions of that image. And there is also embedding of these text and image together. Okay, and the 4 million images are there. So clip are trained on 400 million images text pair embeddings, and they are into self-supervised manner. Okay, so it means what it stand for, clip. Okay, this means it maps both text and images to same embedding space. Okay, so we'll also talk about the RAG today, that how we can leverage this embedding, and we'll see a demonstration of one of the use cases using in the cloud platform, that is how embedding typically works and how you can do embedding on top of images. If you have a PDF file, let's say, and that contains text and images, so how you're gonna decipher it, how you're gonna do this embedding on top of that, right? So embedding is very much important. And the clip is one of the pre-trained model where they store this both text and images embedding a space. Embedding is nothing but it's a vector representation of images and text. Okay, it's just a numerical values. Okay, So for example, if you see this one and image of a dog and the sentence, it says an image of a dog. So let's say you have an image having a dog image there, and the textual representation we have written in the next column that an image of a dog would end up having a similar embeddings be close to each other in the vector space. So I'll also show you through one of the diagram that how vector spaces are very close together. Okay. For example, there might be some images where there will be a dog image somewhere sitting on a tree, maybe below tree or somewhere, right? So the embedding space of this image, only the dog image and the dog image with tree or somewhere, will have the similar embedding as not same embedding, but will have a very close and very similar embedding. Okay. For example, uh, you can say king and queen. Okay. So there will be some embedding, but they will be very close. Okay. Opposite to each other. Okay. Maybe girls and queen, they belong to the same family. So their embedding would sit somewhere very close to each other. So they will be putting in the same cluster. So here we are talking about this one only. So clip is, algorithms where they store the text and images embedding together. They store it and they have 400 millions of images text there trained on it. So it's again, it's a pre-trained text to image model. Okay. And I also show you through this Hugging Face that, how these clip models typically have. Okay. So let me show you this screen. If my screen gets visible, let me come back. Okay. Can you see my screen? Can you confirm if my screen is big?
Yes, sir.
Yeah, okay. So again, let me show you this pre-trained model. So this is, okay. This is Hugging Face. You can say platform, you can say for the people who are, open source developer, people who wants to do some kind of research. So it's a kind of a platform, open source platform, again supported by Google, and we will have a different pre-trained model. And I assume people might have understanding of this Hugging Face. For example, if you want to publish a few papers, you can take some models out from Hugging Face, or even you can create a new models. Okay. And something which are very interesting, you can also use this platform and you can publish it here. Okay, in the Hugging Face. I do have some of the models which are on the Hugging Face. So as a developer, as a contributor, as a researcher, you can leverage this Hugging Face platform and you can use this, for different purposes, and people do use. There are also some of the data sets. If you see, there is a model, data set, spaces, community, docs, and pricing. Pricing is obviously, if you want to use for the enterprise grade applications, then you can use this, enterprise label of, pricing, or, but docs is there. You can see there are different documentations, and the spaces is again how it's like a playground where text to images or maybe image to image models are there, and you can see that their inference, their capability, right? For example, if I have written a cat sitting on moon or something, right? So they will display some images like this, which are very, you don't see in a real life, or maybe you won't see in a Google, right? If you search it, you'll hardly find this kind of images. But when you want to create a new one, you can use this spaces and you can see, how these models works. So let me go to this model section. If you see on the right side, there are different pre-trained models, right? These are some pre-trained models, okay? So the models you'll see in the left side, these are pre-trained models. You'll see there are many, okay? So Microsoft has these models, pre-trained models, okay? NVIDIA has a models, Nemendron 3 Nano. I worked on NVIDIA, so I have an idea of this one also. There are also different models of Microsoft Wild Voice Real Time. You just want to create a real time voice, then you can use this pre-trained model. There are multiple models, and you can use it. So let me go to one of the model, let's say, of NVIDIA. Okay, it's a text generation. Okay, so if you go to this model, this is a pre-trained model. Okay, this one, Nemotron 3 Nano 30B. Okay, this is the model, and you will see their accuracy. Okay, the model's accuracy and throughput. Okay, if you go down the training and everything when this model was published, and what is this model all about? Okay, this can be used for both reasoning on non-reasoning tasks. Okay, so this model which I have shown you can be used for both. Okay, again this is a LLM, large language model. Okay, and trend scratch from the NVIDIA. Again they have a huge GPU TPU, so again they can create their own model. We people can't, but also we can create a small language model. Okay? So these are some of the benchmark you can say. Again, whenever you create any LLMs, so we have some of the benchmark. We compare it with some other models which are available in the market, right? So reasoning model again for text generation, these models can be used, and we have this all the data that can help you also and to understand that how it is being used. For example, it can only text input. The format is string, and they have this input parameter one dimensional, and they take sequential data. They can have input as a 128K tokens. They can take as an input. You cannot give entire let's say 10 pages of input to the this model. Can't. Only can handle is 128 tokens. Okay. So again, it is nothing but it's more of a handling a kind of a context window. For example, if you give a human's entire speech, right? Let's say 20 pages at a time, they will have a very difficulty in understanding and processing those informations at a time. So there should be some limitations. So again, LLMs have some limitations. So 128K is the limitations that this model can have as an input. Okay. And the language that it supports is Italian, Japanese, German, French, Spanish, English. Can't query it in Hindi, right? That is the limitation. So again, whenever you are using any model, at a productions level, you need to see that in which language this model can put a reasoning, right? If it is for global, then you have to see English. Let's say if it is for some narrow market, for let's say in the German market, again, fine. But this model can't be used for the Indian market, right? They cannot create, in the Hindi, right? That is the one challenge for this model. Yeah, language. Then again, there comes a concept of a small language model, right? For example, in India, there are also a few organizations which work for a small language model, which are again for the local language, right? So you can create some of the new content in your own language. Okay. So Bhasini is one of the platform. Let me just write. Now I remember the name. Bhasini. One minute. Okay, so this Bhasini takes some time. So Bhasini is a platform where this the language, Indian language, you'll see the National Language Translation Mission. Under this, there is one platform, Bhasini, and what they typically, they have this kind of, dedicated to the language. They support 34 Indian languages, 23 language services are there, and total inferencing is what they have done is 400 billions of inferencing has already done, and they have 450 total customers, you can say, and again they have 350 plus AI models. They have a pre-trained language models, right? So the Bhasini is a platform. You can also use their pre-trained model, their keys, API keys to create your own model. Okay, and they are aimed to they are solving issues related with e-governance, health, agriculture. So they have all these models across the domain, they have different pre-trained models. Okay, even in the educations they have. So there are different 7+ solutions they have provided in educations. In fintech, they have 3+ solutions. Okay, in the development sectors, they have a few more solutions. Okay, so these Bhasini is one of the platform. You can see how they have used this. For example, the original document was this. This was in English. If you see this one, and now it gets converted into Hindi, right? So again, this is a translations, but just look at the Indian diversity. Okay, so people from the rural area, they do not understand English, and you cannot force them to learn English also. So why not to use AI so that they can have their, you can say, services, products in their own languages. Okay, so again, if you understand your own local language, your cognitive skills increases. So that is why the Indian government has this idea of Bhasini to preserve the local language. It's not like giving preference to the English, but why not using this AI? You can also bring some of the AI element, and you can you know uh, save those endangered language, or maybe the language which are not spoken. So this is the one idea, and also to give to reach to the end people, you can say, to the people who are left out, right? So the AI is bridging the gap. You have to look at that perspective as well, right? It's not again the AI, but how you are using the AI to solve the problem, right? So this is what the Bhasini aims at. Okay, so let me come back to this NVIDIA model. So you'll see there are a lot of uh, you can say descriptions are there. And again, this is your a Python code. If you want to run this NVIDIA, and you can, again, you can run it in your local systems. Okay, you can run it, and maybe if I run somewhere in Google Colab, let's say if it runs, then it's okay. Otherwise, it requires some of the library. Otherwise, it will run, I think. So you just copy it and try to run it. Okay. So if you see this code, they have imported this directly, this pre-trained model directly. Okay. This is a pre-trained model, Nematron NVIDIA. Okay. And these models have, some of, you can say, and parameters, and they are built on. That is why it is passed on, because again, every single LLMs are nothing but it's like a REST API kind of a thing. Okay, so once you go it here, maybe you can click somewhere and you can copy paste. So let me copy paste here. Okay, and just run it. It may run or not run. Maybe it requires some dependency. Okay, so it will run. Okay, so and then if you see this one, this required this RAM and this all these things. Okay, so better to understand all these pretend the models. Go to Hugging Face and see how they have run it. Okay, so entire models and their coding is there. So you just run it and try to tweak it as per your own data. Write a haiku about GPU. So they're gonna write you some haiku. Okay, so you can see, and there are also some of the parameters of these models, and how you can run it. If you have virtual models, VLLM, and also you can uh, create a production grade, using this LLM. Okay, so you can run it. These all are some of the Python code. Okay, so yeah, okay, and these are trained on these many data set or something. Okay, this data set they are trained on. Okay, again, let me go back to my PPT. So we have seen this clip model. Okay, now how this clip typically works. Okay, so clip again. So when I have written, given you can say textual prompt, a kind of a textual prompt, let's say, prepare the Aussie pop. Okay, so this gets converted. This is my prompt. This is my prompt, and this textual prompt gets converted into text encoder. This is text encoder. Okay, whatever I have passed as a prompt, will gets converted into some of the importing. It's importing is nothing but kind of an embedding. Yeah. And then there is some image encoder. Okay. So this is the image. Okay. So image will have, again, there will be some embedding. Okay. So this is again embedding of image, and this is embedding of a text. Okay. And then, this is a kind of a clip. The clip algorithm typically works. They map your textual embedding with the image embedding, and then they store it. So textual and image embedding is this. Okay. They create a pair and they store it in a database. Okay. So clip typically works like this. So they store embeddings of your textual prompt and your image prompt, and they store it in a database. So again, the pre-trained model clip was built on 400 millions of text and image embedding together. Okay, that's all. So whenever I ask, maybe whenever I put a prompt, inferential prompt, okay, so they give me the response like this, okay. So whenever I say a plane, car, dog, blind, something, a photo of, let's say, a dog, a photo of dog. Whenever I say photo of a dog, what they're gonna do? They will take, images from this. They will take images from this, okay. They'll see that there is a dog. So I'll again, my prompt will search into this dog. These are the pairs of dog and image, okay. And they will put some of the diffusion, a new kind of a generator and discriminator. You might have aware of a term called GAN, generative adversarial network, where there is some, you can say the error element, or some kind of a new, you can say a kind of, I'm just forgetting the term, but they add some of the new, you can say the error term to the image. Let's say if it is the image, they will add some of the error. Okay. So that is something called, GAN, generative adversarial network. Okay. So they generate something, new images or text, through this adversarial concept. Okay. So the similar way this clip typically works. Whenever you ask a new questions, if you want to generate a new image from the textual descriptions, they go to your pre-trained model, they check what all are available, and they see they do not give you exact image that is stored in your pre-trained model, but they add some new, you can say the error terms, kind of a diffusion. Okay. And they diffuse it, and then they give you a new image out of that. Okay. That is the difference between Google search image and this kind of a pre-trained LLM based image. Okay. So again, how it is trained, I was talking about, in the back, because typically we do not understand that how new images are coming. Okay. Again, every single time you see a new images are coming, right? But why these new images are coming every single time? Okay. So that we need to understand, because there would be some of the pre-trained, a data set. There would be some images. That is why my clip model is giving me a new, a new images. For example, images with fig fruits without flowers or something. It is written. Okay, image with fig fruit. I don't know what is this, but this is your prompt. That you have given it, image with fig fruits. This is, I think, fig fruits. Okay. And without flowers, that should be without flowers. So again, when you give this prompt to your clip model, they will search through your pre-trained model first, that whether there is some images that is trained on this textual descriptions or not. So they just map it, and then they give they add some of the error terms, kind of a diffusion. They diffuse it, and then they give you a result back. Okay. So this is your data set, typically your data set pre-trained on. Okay. And if you see, this is the result. Okay. So again, they will give you these images, and through this, this clip. Okay. So what clip is doing here? So there is something called zero shot learning scenario. Okay. So only you're just giving this explicit, a prompt that I just want some of the fruits without flowers. So So it's just a zero sort kind of a thing. So there are only few examples that you're giving to the LLMs. But if you are giving some examples that no fruits would look like this and will have not cloud, but fruits would look like this. So you are giving some of the images in your prompt. Okay, so that would come under kind of a few sorts. You are giving some few examples. Okay, so your you can say then your responses, your reply would be totally different. So when you are having this zero shot prompt, the response would be different, and when you have this few shots, then your images or maybe the responses would be totally different. Okay, so that is why the prompting techniques, how you play with the prompts, give you the desired in the output. Okay, so that is why that is more important while inquiring with this kind of a models. Maybe it's a text to text or maybe text to image. The concept typically works in a similar fashion. Okay, so again we have this text to image. Okay, so just give me 30 seconds. Just give me 30 seconds. Yeah, hello. Am I audible? Sorry.
Yes, sir.
Yeah, sorry. Was someone at my doorsteps? Okay. So image to text. There is something called a visual captioning. Okay. So how we are let's say we have some images and how we put some captions, right? For example, captioning means let's say I have given some images to GPT model, and I just want to understand what this image talks about. Okay, it's more about there is one term called verbalization. Okay, I'll give you this demo today, that how this concept of verbalization, image verbalization, our model gives us a response which are like a human response. Yeah. So visual captioning is, again, we have some images as an input to GPT model, and it gives a response like a human readable format. Okay, human can understand, a kind of a putting reasoning on top of images is called a visual captioning. Okay, so let's say this is one of the images where traditionally we just wanted to understand, when there was no concept of transformer model, when we only had this our traditional, you can say, the classical machine learning model at that time. So we have this convolution neural network and a recurrent neural network. Okay, so the idea behind this transformer model, you can say, was this CNN RNN. So it's again it's encoder decoder framework. So that is more important because it is being asked, everywhere, even in industry or maybe in academics. So I have faced a lot of this encoder decoder framework. Okay. So what is encoder and what is decoder? Okay. So GPT is only decode, is used for decoding. So you just give some prompt and they give you some response back. So that is decoding your input. So that is a decoder framework. But there are models which are used for encoding and decoding as well. So for example, transformer models have this encoder and decoder features. So whenever you give some input, they encode it. Again, they create embedding on top of it. They store it, and at the output level, they decode you. Okay, so what you were trying to say, that will be decoded at the end. So encoder and decoder framework is new advancement, you can say. So there are models you might have aware of that there is one model called T5, and that is for maybe by Google. And there are some model, BERT model, BART model. There are many models, FinBERT, if it's related to financial, kind of, inference you want, then FinBERT is there. So there are many models which are pre-trained, but they are discriminative pre-trained model. There are two concepts of generative model, and there is something called a discriminative pre-trained model. Okay, so it's very new. And when you say a discriminative pre-trained model, so we have a BERT, BART kind of a model. Okay, so they have some limited, you can say, uh, data that they are trained on, and that's all. They do not generate anything, kind of a new content. They do not generate any new content. They are like a static, but again, they have a pre-trained model. They are again, they have works similar way that GPT works, but they are discriminative one. But when it comes to generative, they generate a new content, like, they human can understand. Okay, so that is why they are generative pre-trained model, the GPT. Okay, so if you see this one, CNN, they use this image first, typically earlier. So this image, gets, have some of the embeddings. So that will be mapped. So every image pixel wise, it is mapped. Okay, and their features are stored in a pixel wise. Okay, so CNN has ability to store textual, the image. You can say their, you can say image wise or pixel wise informations. They call it a feature. Every single pixel is now it's a feature. They store feature. Okay, image features. Again, image feature is nothing but storing it in an embedding format. Okay, in some of the numerical format. Okay, and then we're applying this RNN at a decoder level. Okay, so when you apply RNN means they convert the image feature into textual representation. So that is why you are getting a woman swinging a tennis racket, right? So that is why we are getting like this. Okay, if you remove this RNN, we will not get, textual, visual captioning, more of a textual, understanding of these images. Okay, but again, this entire layer is being replaced by the transformer models because they have inherent capabilities. And again, it was replaced by the GPT. So GPT is built on top of transformer models. So they understand your image features, and then they put a caption, kind of a, you can say the verbal reasoning on top of it. Okay, so then you get it entire, whenever you put some images to GPT model, you get, a kind of a response. They can easily verbalize those images. Okay, so entire these concepts, CNN plus RNN, is being replaced by the transformer models. Okay, so again, similar way, if you pass these images to your GPT model, you'll see some kind of response. Again, when you used to train your model through RNN or CNN, you used to have this kind of a probability. Like this is Apple will have some of the probability. Okay, transformer, PyTorch. There are some of the library that we typically use to have the identification of these object detections with some of the probability. Okay, but again, all these things are replaced by the transformer models now. Okay? So again, visual question answering. The second, this examples, again, you can easily identify, the backpack, mountains, dog, all these scenarios. So through this visual caption answering, so if you have some of the pre-trained models, earlier we used to, create a model from the scratch, used to create from the scratch from the data which used to available. But again, when data changes, right? So it creates a lot of a problem, right? Because there is something called a data drift. For example, you have trained a model using a data which are very recent, but again, after a year, if you use the same model, your predictability will decrease because they have not seen the new data and you have trained on the older data. So that is again the model drift. Okay, so again, whenever in a industry level, people do see that whether there would be some data drift, there would be some a model drift in near future, and then they try to incorporate it. Then again you'll see this concept of the version 1 is launched, version 2 is launched. Why? They just want to eliminate this data drift and model drift kind of a concepts. Okay, so again this photo is for the the same visual question answering, and again it's built on top of the pre-trained model. If you see this one, this is a pre-trained model. It is not using CNN and RNN. Now it is being replaced by the transformer models, but they have this visual QA model. Again, this is a pre-trained model. You need to directly pass this only test data. Okay, you do not need to train your model from scratch because it is already trained. That is why it is called a pre-trained model, and now you're passing this input to the model, right? And now it is giving you some of the response. Is this photo taken indoor or outdoor? It's a kind of a classifying this image, whether a kind of putting some labels. Okay, label is here outdoor. We are putting some label to image. Using this visual question answering, it is again a pre-trained model on top of transformer architecture. Okay, so again everything is being replaced by the you'll see the pre-trained model. Everything now people do not want to train their the model from the scratch, because again it requires a lot of TPUs, GPUs, a lot of a time. You burns many bills, right? So that is why to eliminate this one, again that is why this Nvidia, Google, Microsoft, they have their own models. Okay, they do not want to put resource in training every single time. And okay, so let's have a break of 10 minutes and then we'll come back around 11:30. Is it okay?
Okay, sir, sure. We'll have a break of 10
One
minutes.
demo, and yeah, we'll see a short demo afterwards. Okay.
Dear participants, there is a short break of 10 minutes. We'll join back after 10 minutes. Please be there in the session.